You know, for a clock that's 200 years old or something, it's not bad, is it? It's not bad.
That was pretty good for effect there, Paul.
Hey, listen, welcome to Slooh. This is a public Slooh star party. Slooh is the home of social astronomy since 2003, where members have been controlling Slooh's robotic telescopes and sharing the night sky in our global community. I'll give you a quick flash, actually, of our global community, because Slooh members can actually join the Slooh star party. There's a quick flash of everybody there. Get them off screen because we're not looking at them tonight. We've got a very special one tonight. It's one of my favorite celestial events of the year. And before I introduce my co-host for tonight's Star Party Live, I want to tell you a very brief little story, and it is brief, it's only a minute or so, but it kind of sets the scene for us tonight. 158 years ago, July 1862, two astronomers, one named Lewis Swift, the other one was Horace Tuttle, discovered this lump of primordial space debris, a ball of ice and dust around 26 kilometers in diameter. That's 16 miles across. And it's actually about the size of the object that wiped out the dinosaurs. But anyway, those two astronomers, they worked out this object's orbit, and they realized that it went around the sun every 133, if you want to be really fussy, 0.28 years. They had discovered the 109th periodic comet. It was named 109P Swift-Tuttle. Now, on its journeys into the inner solar system every 133 years, it crossed Earth's orbit. And Swift-Tuttle is an absolute cosmic litterbug. It leaves behind it a trail of dust and debris along its path. And it's this very fact that brings us to our event tonight, the most popular meteor shower of the year, the Perseids Meteor Shower. Now then, to tell us about the comet and meteor shower and how those two things are connected, I would like to introduce my co-host for tonight's Star Party, Dr. Mike Shaw. Good evening, Mike. So what is the connection between Comet Swift-Tuttle and the Perseid Meteor Shower?
Good evening, Paul. Well, that was a wonderful introduction to place the context of this majestic event, which is occurring on a scale of at least the solar system. So it's a wonderful question, and it all goes back to what is a meteor and what causes a meteor when we see this to occur. A lot of times you'll have people refer to meteors as a shooting star, and it does look like a star. It's very bright and it's a pinpoint of light. But a meteor takes place in the Earth's atmosphere, so it's actually very close to the Earth. It's only a few dozens of miles above our heads when it's taking place. And the meteors that occur are little, as you'll be talking about later this evening, a result from a tiny speck of dust that was left behind from this cosmic litterbug. So this huge trail of debris that Paul was talking about just a moment ago, we're going through that. We're kind of fighting our way through it and trying to, we can't really dodge them, but all of a sudden every now and then they come blazing through the atmosphere, as we'll be talking about. And so we're getting a little taste, if you will, of the comet's residue each time we see a meteor in the sky.
Exactly. And we're going to talk all about what meteors, meteoroids, meteorites are, the difference between all of those. We're going to talk a little bit about comets. We're going to have a look at some of the comets that Slooh members have captured with the robotic telescopes over the last 17 years or so. We're going to answer your questions. So Sloothians, you can go into Slooh chat and ask us any questions there. So we'll keep an eye open for that. I need to tell everybody about the feeds that we've got tonight. We've got two feed partners. Let me just make sure I didn't click on something. No, sorry, we are juggling quite a few quite a few feeds tonight, and this little lot comes from the Sharjah Academy for Astronomy, Space Sciences and Technology. Now, the University of Sharjah are our observatory partners there. We were due to be building an observatory there this year, but of course the pandemic has slightly interrupted that. But what all of these, they have a whole collection of specialist meteor cameras, and they have them in several locations in the Middle East. Because if you spot a meteor from 3 different positions, you can tell an awful lot about it. You can tell its direction, you can tell its speed, its trajectory, you can work out where it emanated from in its orbit. So these are all little thumbnails, and we can see there the moon is up because it's 3 a.m. there at the moment, and that's actually classic meteor watching time. So we've got them. They're actually these cameras are 450 kilometers from Sharjah in the deep desert. I mean, the technology to kind of bring this stuff to us. We need to keep our eyes open in these. I will check with them as we go through the star party what the conditions are like. We can see the moon, but we can also see that it's a little bit muddy through the cloud. But in 10 minutes time, we've got our partners at the Institute of Astrophysics at the Canary Islands. Oh, sorry, I did just want to mention actually 2 people in Sharjah. There's Dr. Ilyas Fanini and Issam Abu Jamil, and they're setting that little lot up for us. Now, over in the Canary Islands, which I'll show you in a minute because it's looking really, really good over there. 10 minutes time, we got the live feed coming in from there. And that's the Institute of Astrophysics of the Canary Islands. So that's 300 miles off the west coast of Africa. And that's where Slooh's flagship observatory is, where the big telescopes are that Slooh members control every night. So if you're not a Slooh member, then please consider joining. And you can control those telescopes every night. And you can watch all of the live feeds. You know, Slooh members do this stuff, this social astronomy, every single night. Now, I want to thank Dr. Miguel Sarah Ricard. He actually manages that entire site where some of the world's largest telescopes are based, and also Miguel Rodriguez Alasson, who is actually setting up the feed for us. So that's going to be starting in 10 minutes time. Now, I think that actually is a good time for me to show you the observatory, because I was looking at it just before we started. So let me, right, let's get over here. This is the Slooh website, by the way, if you haven't seen Slooh before. By the way, I'm Paul Cox, Slooh astronomer. I always forget that. Hello, everybody. I've been working for Slooh for longer than I can remember, and I enjoy every minute of it. But let's take a little look at the observatory. Now, look at the date on this. This is a little time lapse from last night. You see night sky. We had 2 star parties last night. Let's turn on the time lapse. Here we go, Milky Way going across. Moon is rising. Look at that. That might be a problem for us a little bit later. You can see the enormous telescopes. Then it's daylight. And you can see Mount Tady there in the background. We're above the clouds, 8,000 feet altitude, 2,000 meters. Then we come into tonight. Sun is setting, sun is setting, sun is setting. It goes dark. There's no clouds. There's the Milky Way. But look, there's something really quite peculiar that you don't normally see up on the top of the mountain, because it's usually only astronomers up there. But if we look at the current image here, look at this. The road is absolutely packed with cars.
That's amazing.
You can see even there are lights along the observatory roads as well, because during the Perseid Meteor Shower, everybody from the island basically drives up these really winding roads, which are great fun to drive, especially in a very fast car. And they go up there, and the whole, I call it a mountain, it's actually a volcano, but the whole thing, when you're up there, it's a marvelous experience, because there are just shouts of oohs and ahs and wow, did you see that one? Normally in Spanish, actually, not in English, with everybody watching them. And they'll be up there for a good few hours. And this is where our our live feed is going to be coming from a little bit later. You can see here as well, this is a view actually from 10,000 feet altitude, and we're looking down on the observatory. That's where the observatory is, where these lights are. And as I say, usually there aren't any lights here at all. But anyway, let's take a look. Andrew, is your feed up and running?
Looks to be. Can you hear me?
Yes, I can. Yeah.
Wonderful. Yeah, I've got it in the all sky mode at the moment, and we have cloud, unfortunately.
Okay. Actually, I've just got to do one little thing. Stop some feedback for me. You've got a bit of cloud. Have you got any clear sky at all?
Not at the moment.
Not at the moment. Okay. Oh, there it is. I had lost it. Okay. So Andrew Dumbleton there is Slooh's operations manager. You're near, it's the Midlands, really, of the England.
Yeah, it's a town called Nuneaton. So it's near Coventry and Stratford-on-Avon and Warwick, right in the middle of the UK.
Okay. And here you've got this kind of all sky view, really wide field camera. We can't see any stars there, and that is because of the cloud. Is that?
That's correct, yeah.
Okay, so if we can't see stars, we're not going to see meteors. Now, I'm totally clouded out down here as well in the southeast of England. So up until another 5 minutes, we'll keep an eye on the Sharjah feed, because if we can see the moon, then we might see some bright meteors through some of the cloud that they've got. But 10 minutes time, 5 minutes time, we've got the Canary Islands coming online. So that's going to be pretty cool. So back to you, Mike. Meteors, what are they? We know it's this debris, but there are three things that people get confused with, aren't there? There are meteors, there are meteoroids, and there are meteorites. Can you tell us what each type of object those are?
Yeah, it is very confusing because they sound so similar. And it all begins really with a meteoroid. So the oid is like the little grain of sand or the little pebble. And that's really all it is. If you think of a pea or a chickpea or just even a grain of sand or a tiny little rock, that's all these things really start off to be. And as we were just talking about, when a comet is passing through space, it's, you know, kind of getting close to the sun and releasing these tiny little rocks into space that slam into the Earth's atmosphere. And before they hit the atmosphere, those are called meteoroids. And one way to remember that is it sounds a lot like an asteroid, which is a bigger chunk of rock, which is, you know, out in space doing its own thing. But a meteoroid is a tiny little meteor to be, if you will. Now, once it hits the Earth's atmosphere, what does it do? It starts to rub against the, you know, we just had a successful landing of some astronauts a few days ago. We have to worry about the heat shielding to keep them alive, to keep them safe. What happens is as these meteoroids pass through the Earth's atmosphere, they're going at tremendous speeds, what we'll be talking about. And the Earth's going at its tremendous speed. There's a lot of tremendous speed and there's a lot of friction. So when you rub your hands together like this, you can feel the heat. And that's what happens to these little rock particles as they are passing through the atmosphere. So when that happens, the air heats up and gives off light, as we'll be talking about. And we see that light. So the light that we see is actually the light from the air that's being heated up by the rock passing through it. Now, that light, it's obviously a very straight trail. That is called a meteor. So if you think of the tiny rock particle, the incandescent trail of gas left behind ionized air, that's the meteor. And if this tiny little piece of rock that just hit the Earth's atmosphere makes it all the way to the ground and you can pick it up and hold it, then you have a meteorite. And if you ever get a chance to see a meteorite, well worth it. So you have meteoroid, meteor, meteorite.
Okay, and the meteoroids, most of them, I mean, you talked about the size there, the vast majority of them are the size of a grain of sand.
Yes.
The larger ones are the size of a pea. And when we see one of those, they burn up in a way, they vaporize in what we call a fireball, and they are spectacular. But how come you mentioned the speed there? How can such a tiny speck of sand, somebody got some music playing? They could mute, please. Thank you. How can a tiny speck of sand generate such a huge amount of energy?
No, it's incredible, isn't it? So it's a great question, because when you think of a grain of sand, I mean, you could hold up a handful of sand in your hands and let it dribble through your fingers. Well, what's happening is, in space, when these this debris field, all these these grains of sand are floating around in space, being left behind, they actually have a speed relative to the Earth of tens of thousands of miles an hour. And the Earth is moving at tens of thousands of miles an hour. So when the Earth collides with these, you have this very high speed differential. And what happens is, in effect, the Earth wins. It's like if you're driving and a bug hits your windshield, well, you just keep on going. And that's what happens with a meteor.
Did you see that? Did you see that?
I caught a flash. Was that a meteor?
It was indeed. Over on the left-hand side, that is our first Perseid Meteor. Look at that. I just switched to the feed.
I got a little bit of a flash, and I was like, oh, yeah, it was a thing. So great spotting that one, Paul.
That's great. This is the live feed coming in from actually the neighboring island, because we've got two feeds coming from the Canary Islands tonight. We've got this one coming from the neighboring island of La Palma, where they've actually framed one of the telescopes there against that background sky. So, wow.
That was amazing.
What perfect timing. That's pretty cool. So this is going to be our primary feed tonight, because it's an incredibly wide field. We've got very clear skies there. So, gosh, I think our work is done here, frankly. I think we can all go to bed now, can't we?
Yeah, that's a wrap. We're just getting started.
Okay, so tiny speck, tiny bit of mass, but producing an enormous...
Oh, that was a big one. Look at that.
Another one.
Oh,
do you see?
Wait, I was actually joking about the headlights, but I did see that.
Yeah, another one just came in from the left. So we know roughly the kind of direction there at the moment. Yeah, somebody's going to be getting a lot of trouble for switching those headlights on. You can actually see somebody was driving up there. It's the Canary Islands, by the way, are a world-class astronomical site, and they have a light law there. Which
really?
Prohibits any form of external lighting. So the street lamps are all full cut off. You can't have big floodlights and stuff like that there. And the observatories themselves are closed to the general public, because the last thing you want is for people to be driving through those locations. Now, we got this feed for the next couple of hours. Mike, I don't know if you can make out where we're looking, but I think I can see the Andromeda Galaxy.
I think that's what that is. Yeah. No, I was looking at that, seeing if I could make out Perseus and below it and to the left. I think I agree with that. That's what I think.
Okay, so now we've switched over to the Observatory del Teide. So this is where Slooh's telescopes are located now. That looks like we're looking at the Milky Way.
Yep, Sagittarius on the left. You can see Teapot, and you can see the Lagoon Nebula at the mid upper right. The center. We're looking right at the center of the galaxy, actually.
Yeah. Wow. So this is very cool. Oh, did you see that?
No, I didn't. Did I miss it?
I think that. Did anybody else see that? Thumbs up, thumbs down, flash.
Okay, there we go.
Middle down to okay. Listen, we have done so many meteor shower star parties over the years, and we have on occasion sat here for hours together and not seen a sausage. But tonight we've already seen 3, so I think that's a fairly auspicious start.
Way to go 2020.
Anyway, going back, I mean, this is going to be our problem tonight, isn't it? Because every time we try and start talking about something, we're going to go, oh, look, do you see that one? Do you see that one? So anyway, right. Tiny speck.
I'm sorry, I got to digress.
Go, Mike.
So, for those of you who may subscribe to Astronomy Magazine, this month's, or the August month's column by Bob Berman talks about this excitement. and how it never gets old. And it's just one of these things that when you see one of these phenomena, it's just exhilarating. So I just wanted to
Bob's excitement is infectious as well, and he does loads of tours and stuff like that, and takes people off eclipse watching and meteor watching and all sorts of other things, and it's just absolutely infectious. But that's what so many of us who are into astronomy and love to do. Part of the fun of it is sharing our enthusiasm.
It is.
Yeah, and for me, the little bit of knowledge I have, for you, Mike, the huge amount of knowledge. But anyway, let's go back. So we've seen a couple of, somebody's reversing now, we've got a red light there. Yeah. So we've seen this enormous flash of energy as this tiny sand grain particle vaporizes in the atmosphere. Now this is happening.
Oh, wow. Oh man.
Yay. Well, so we could really see some color there, and that color is not artificial. So I'll get Mike to talk about that. But that's a classic example. Now that one, I would say, is closer to the size of a pea. So that little bit of debris that came off Comet Swift-Tuttle was probably about the size of a pea. But still, that's stretching over an enormous swathe of sky to see that. And it's because of its velocity. It is entering Earth's atmosphere at 133,000 miles per hour. That's 60 kilometers per second. And that's what generates it, and it pushes the air in front of it, and as Mike was saying, that heats it up. So I think the kind of temperature that the actual meteoroid reaches is something like 3,000 degrees Fahrenheit, and that's what vaporizes the
cooker
thing.
It's like a little furnace.
Mike, what's causing the color there? That looked an absolute classic Perseid green to me. It's not because it was a pea. Why is it green?
Great question. So really, it's the dissociation of the oxygen molecules in the air, and the oxygen. I saw your mouse go across, and I thought, oh my goodness. Sorry. So so what happens is, if air is 80% oxygen and 20% nitrogen, roughly. There's some hydrogen and helium and carbon dioxide and so forth, but it's mostly oxygen and nitrogen. And when this particle of sand comes scorching in at these, high velocities, if you may remember back to your high school physics, it's the kinetic energy is a half mv squared. So as Paul was saying, the velocity is super important. It's the square of the velocity. So if you take a huge number and you square it, you get a really huge number. And that's why these particles have so much energy. And you may recall that energy is conserved. So you have this kinetic energy from this particle. It comes scorching into the Earth's atmosphere, and then it disappears. Well, if energy is conserved, it had to go somewhere, and it gets converted into thermal energy, into this dissociation of the molecules' energy. So when you rip those molecules apart, you have to supply energy to do that. When you do that, then you create this this greenish color. You can see some magenta color, which is from the nitrogen atoms and ions being dissociated and ionized. But it's really from the air molecules themselves. So it's not so much from the composition of the pebble itself. A lot of times people think that, but that's why all the meteors you're going to see roughly have the same color, because we're looking at this very narrow tube. It's like a needle of ionized air that's giving off the same colors from the ionized oxygen and nitrogen.
I mean, that looked like it was fairly low, but we'll talk about, where to see Perseids a little bit later. But this is actually occurring about 97 kilometers in our atmosphere above sea level. That's about 60 miles or so. So this is happening a long way up. And Mike, what you were talking about earlier, you were saying, when you're describing the difference between a meteoroid, which is the grain, the meteor, which is the actual fiery train that we see, but then the meteorite, it would be pretty darn rare for a Perseid meteoroid to make it all the way down to the ground, wouldn't it? Because they burn up. An object actually has to be pretty darn big to make it through the atmosphere. And even when you do find a meteorite, then it's a tiny fragment of what's left and what has burnt up and vaporized when it's come through the atmosphere, isn't it?
Absolutely. Yeah, actually, it's an interesting thing. I don't want to digress too much, but there's a very interesting project going on. You can read about where there's a scientist who's studying what's called micrometeorites. And these are meteorites, so they've actually landed. And what the scientist does is they go around to rooftops, just in downtown cities, and they kind of vacuum up just a little dust on the rooftop. And then they take a super powerful magnet that you might use for dredging in a lake to try to see if you can dredge up things. And they separate out these very metallic meteorites from the debris that's on these rooftops. And then they look at what they get under a scanning electron microscope at very high magnification. My point of saying this is that there are literally dozens of these little meteorites. Do we see one?
Well, actually, that was going in the wrong direction. So we'll talk about that in a second, Mike, because we're going to talk about, Perseids, how many we can see, where we'll see. Sorry, carry on.
Yeah. Oh no, and that was just about it. So I mean, when I learned about this research project, if you want to find out more, you can search micrometeorites and rooftop buildings and scanning electron. And there's these beautiful pictures. And what happens is these things, when they're examined at very high magnification under a microscope, they have a very they look like little marbles. Because what happens is as they're coming through the atmosphere, they actually melt and become little globs of molten rock. It's just, little, and then when it comes back down and slows down enough, they re-solidify, but because they are like little droplets of metal, they form little, like instead of being raindrops, I guess you'd call them meteor drops. And there's a beautiful thing. My point is, I'm actually surprised at how many of them there are. And most rooftop buildings might have a few of them. So it's just an incredible discovery.
I've forgotten what the actual quantity was, but it's an absolutely astonishingly large number of, I think it maybe even goes into certainly hundreds of tons, but I think it's even tens of thousands of tons of space debris actually makes it, into Earth's atmosphere every single day. It's an extraordinary number. But anyway, what we need to talk about now, I think, Mike, is how many meteors can we normally see? Now, the Perseid Meteor Shower is not the highest rate of meteor showers during the year, but it is the most popular shower, and it's because it happens during warm summer evenings, so it's an easy shower to see. A lot of places have clear skies, except for old Andy Dumbledon
and Minnesota, actually, tonight.
Oh, and Minnesota, so, okay. So there's a few of us. I mean, thank heavens for Slooh. Thank heavens for our partners, the EAC, the Institute of Astrophysics of the Canary Islands, and Skylive. Skylive.tv, by the way, the group that is sponsored by the EAC, and it's an organisation, a non-profit that is run by Dr. Miguel Sierra Ricard, who manages the observatory site. But what we hear, and it's such a shame because I think it builds up a false expectation. We hear figures bandied around that you might see 100 or 120 Perseid meteors an hour. And sometimes, in the same story, it might say under ideal conditions. But you just don't see that number. And even when it's reported kind of properly, 50 to 75.
There went another one.
Whoa.
Sorry. Cool. That's amazing.
Very cool indeed. So there's our one for that particular 5-minute slot.
Hey, Paul.
Yes, Tom.
I just want to bring up a comment Frank made in chat, which I think is very interesting. If we happen to miss one of these, there is a 30-second delay on the YouTube playing within the show page. So there is a potential second opportunity if a good one passes by.
Fine.
Okay, that's great. We'll show the page a little bit later. So, but personally, I don't want to see the rerun. I want to see the live.
I mean, this is really quite amazing because this is a decent view of the sky, but it's not an incredibly wide view. And to have that many, we're looking pretty close to the horizon. I have this feeling, and
Yeah, we are. We are looking very low, actually. So anyway, back to how many we see. So let's take one little step back, because something that surprised me, I only learned this earlier this year, is we're talking about this debris field from Comet 109P Swift-Tuttle that orbits the Sun. Oh, that's a nice one coming down.
Oh, missed that one.
Top left. Oh, people missed it. So orbiting the Sun, it goes all the way out to Pluto, and it crosses Earth's orbit when it comes close to the Sun every 133 years. So we talked about it being a cosmic litterbug, leaving behind this trail of debris and dust. Now, these meteoroids that we're seeing, this stream of material, this river of material that it leaves behind, each one of these sand grain sized specks can be between 60 and 100 miles apart from other meteoroids in that train. This is an incredibly sparse field. Imagine a grain of sand, and the next grain of sand is 60 to 100 miles away. That's how dense this field is. So, oh, that looked like a reflection of one in that mirror of the telescope. Anyway, so Mike, sorry, getting a mosquito thing. Talk about how many meteors, how many Perseid meteors people will actually be able to see. Let's get rid of the hyped figures. How many can people actually see?
Well, it's a great question. And the most important thing to seeing them is to be outside looking at the sky. And we'll talk about when to do that.
Is to be watching Slooh's live coverage.
Or,
we have feeds in multiple places around the world to see Mike. No, your time here is finished, Mike. Sorry. Move on.
Oh, that's so true, isn't it? Oh my gosh. But yeah, so
you're right. Outside, if you've got clear skies, I always recommend people, if you've got clear skies, listen to our Star Party as your audio track.
There you go.
Your own meteor watching outside.
There you go.
That's a good fun way of doing it.
There you go. Well, it's, I mean, realistically, here are numbers of on the order of, as Paul said, under ideal conditions of 50 to 75, maybe even 100 meteors per hour. But that's under ideal conditions. And what does that mean? What that means is that you have a completely unobstructed view of the entire sky. So it's basically you're in the middle of the ocean with nothing blocking any part of the horizon or the sky. And you're so far away from any urban lights that you have a completely light pollution free, dark environment. And the moon is far below the horizon. So there's no moonlight or sunlight or anything interfering with things. And it's past midnight, so it's in the early morning hours. So because there's a time variation. So, realistically, if you see, maybe a dozen or a couple dozen an hour, you're doing pretty well. I mean, the numbers that we just saw here are amazing. And the other thing about this is that as you just saw, perhaps most meteors only last a fraction of a second, let's say 1/10 of a second or 2/10 of a second. The bigger ones last for several seconds, of course. But the numbers that you'll hear quoted refer to all the meteors that you might be able to see if you're looking everywhere in the sky. And of course you can't. So you're only looking at part of the sky at one time. There's an axiom in the type of night photography that I do with my camera that the meteors are always occurring behind you. When you're pointing your camera this way, they're going to be over there. So just temper your expectations, and it's a multi-hour event.
There was one.
Oh, I totally missed that one.
Just coming down. Now, again.
How many is that? That's like almost 10 now.
But that was coming from the wrong direction. So, Mike, just go back to your point there.
Yeah.
Under ideal conditions. And I normally, when I'm outside, we'll maybe talk about how people can do this in their own backyard and some of the tips of doing it. But I normally just look straight up. And there's a trick to meteor watching, I think. You can get tunnel vision and you start focusing on a particular bright star or something like that. And it means that you start missing the meteors in the periphery. But if you just almost get so relaxed that you don't focus on any particular star and you just become conscious of what you can see in your periphery. I'm always surprised at just how quickly you can then avert your vision to actually look directly at the meteor as soon as you catch a slight glimpse of it. So Perseids for me, when there's no moonlight, when you're under ideal conditions, after moonlight, I would consider myself lucky if I saw 10 an hour. Right?
Yeah, I would say that's realistic.
Yeah, you know, 20 an hour. I don't think I've seen 20 hours.
Hey, Paul.
Yes.
I'm sorry for interrupting, but there's a few people on the chat that are saying they cannot hear you.
Oh, really?
Yeah, you sound very low.
Oh, I see. Okay, so just low, but they can hear me. Okay, so I'll try turning my gain up again, which I did yesterday. Might get a bit noisy though. That's the problem. How's that? Is that any better? Is that any better? Is that better?
Yeah, I think so.
Is that better? Okay. So sorry about that, folks. I'll move the microphone right up here. How's that? Is that better? Or is that just a bit creepy? Anyway, 10 to 20 an hour, and that's enough to keep you entertained. It's enough to keep kids entertained, and that's an important one. But as Mike said, when he's photographing Perseid meteor showers, whichever direction the camera's pointing, you know that they're behind you. And when you're out meteor watching with a group of people, there's one thing that's guaranteed. As soon as you look down to pick up your hot drink or something like that, everybody else goes, "Wow, did you see that one?" And no, you didn't, because it was the one moment when you chose to look away. But 10 to 20 meters an hour, when they are Perseid meteors, when they can be really quite long and very bright, are certainly worth spending a night out under the stars, especially when it's a warm summer's evening. So, Mike, what else? We're talking about. You were saying we're looking quite low. I know what I wanted to say. We saw a couple of meteors. We have seen a couple of very short ones, which did not come. What we know is the radiant of where most of the Perseid, where all of the Perseid meteor showers will appear to emanate from, is in this view on the left of the screen. But we've seen two shorter meteors that haven't been pointing back to that location. One of them came from the top, lower down.
Right.
What's that?
Yeah, it's a great thing. So this is the beautiful thing about astronomy is any night you're going to go out, you're likely to see sporadic or random meteors like these. And they have nothing to do with the comet Swift-Tuttle. They're just random debris that's floating in space. And you might see maybe if, on a good night under ideal conditions, half a dozen per hour, which is, once every 10 minutes. I mean, meteors are actually relatively common if you get away from cities under a dark sky, but they're not particularly associated with a meteor shower per se. And so they're called random meteors or sporadic.
Oh, and was that one as we just saw it? But anyway, sorry.
So something, but then so they can be of any duration. But can we talk about Earth Grazers now? Is this a good time to talk about that?
Yeah, go. Earth Grazer. That sounds like a large herbivore.
It is a large herbivore. So what we may have just been seeing. So what happens is, just like everything else in the night sky, the origin of the meteor shower, which we call the radiant, because everything seems to be radiating from that. And the radiant is located in the constellation Perseus, of course. The radiant is in motion because the Earth is rotating, so everything appears to be moving. And in the northern hemisphere, what we tend to see is the radiant becoming higher and higher and higher in the sky as the night progresses. Now, when I have another axiom for night photography is when you're setting up your gear, that's when you see the biggest meteors. And the reason for that is you do that early in the evening when it's still twilight. And at that time of night, the radiant is either very low in the horizon, as it is for us in northern latitudes, or it's even below the horizon as you get closer to the equator. So what happens is, their meteors are happening day and night. We can only see them at night because the atmosphere is cleared up because the sun has set. But what happens is if you're able to see a meteor in the early evening when the radiant is close to or below the horizon, that means that it has to come all the way across the top of the atmosphere to reach you, so you can actually see it. And for that to occur, it has to correspondingly be a fairly good sized meteor. So these tend to be very long, bright, vivid meteors that are spectacular. So yes, there's an argument for certainly seeing the most meteors in the early morning hours, but in the evening, it's not bad too. And you might be able to see one of these, and they're called Earth grazers because they're grazing the top of the Earth's atmospheres. And as Paul was saying, if you're able to sort of dissociate and just look off in the distance and your eye catches one of these, you can actually watch, just like we were seeing here, you can actually watch this thing go across the sky, almost like in slow motion. It's like when you're, bike wreck and you can see it all happening. You can watch this thing and it's like sparkling and breaking up into pieces. Just magnificent.
So what we're looking at now, so we've got our live feed from the Institute of Astrophysics at the Canary Islands and our partners at skylive.tv. This is coming from Observatorio del Teide, which is the OT. It's on the island of Tenerife, as you can see. This is where the Slooh telescopes, robotic telescopes at our flagship observatory are based. And this is a very popular region of the sky that we're looking at here. So we're looking south, we're looking at the heart of the Milky Way, loads of, actually a lot of our seasonal gems for all of our quests are located here. We can even see a couple of them here. So we're looking south here, but we know the radiant, Mike, is in the constellation of Perseus, which is a northern, it's fairly close to the North Celestial Pole. So if we're looking down south, can we really see a Perseid meteor down here?
Oh, it's an amazing thing to think about, isn't it? Because I was thinking about bringing a globe along for the night's show, and I'm kind of regretting not having it. But yes, what happens is the geometry of the where the radiant is in the Milky Way, in the cosmos, in the universe, so to speak, and the Earth is. I mean, the Earth is, we tend to view the horizon and then, the sky above us as what we see. But in actual fact, these meteors can actually come over our heads. So if we're facing north, so if I were to, if I was to face my screen, I'd be facing south. So looking at you right now, I'm facing south. If I were to turn around and look at my bookcase, the meteors would be coming from the bookcase. So for us to see this on the screen, they'd have to come from behind me, over my head, and then come launching down so that I can see them on this view looking south. So absolutely, you can. That's the beautiful thing about a meteor shower is you have a reasonably good chance of seeing a meteor no matter what direction you're looking at. So, Paul, if someone were to say to you, "What direction should I look?" What would you say?
I normally tell people that I look directly up. I lay I lay reclined when I'm meteor watching, lay reclined and try and just see from horizon to horizon. And as I say, it's so surprising just how quickly one catches your eye, even if it's quite far off. What I never do, and what we wouldn't recommend to anybody, is if somebody looked up a sky chart or some of the media articles about the Perseid meteors have got little charts and they show this radiant in the constellation of Perseus. Don't look at that, because if you're looking directly at that, most of the meteors, most of the Perseid meteors that you see there are coming almost directly towards you. So they're very, very short. It's the total opposite of Mike's Earth grazers, which are traveling, they're a long way away from the radiant and skimming through the atmosphere. So you can see these any way you like, but I usually just like looking generally up. The other thing at the moment is we haven't got, the moon hasn't risen quite yet, but we do have this just past last quarter moon, and moonlight will light up the sky and it will block out all but the brightest meteors. But if you're outside observing in your own backyard, you can really mitigate the impact of the moonlight just by making sure that you shield the moon behind a tree or behind a house or behind something. So you can't directly see the moon. You might see, the the moonlight around it, but you can't directly see the moon. That's going to do two things. One, you're not going to see meteors close to the moon anyway, but it's going to protect what's called your dark adaptation. Now, Mike, tell us a little bit about dark adaptation, because this is important for general astronomy, let alone when you're meteor watching, but it is really important when you are meteor watching if you want to catch even the faintest Perseid meteors.
Definitely. So so this is a crucial point, Paul. I'm glad you mentioned that. The key thing is to turn all the lights that you have off and to give your eyes a chance to adapt to the dark. When what that means, it takes a process that really takes about 20 minutes to occur, and it can only fully occur under the absence of all natural, all human light, human source light. What happens is, as you probably know, the human vision system that you're using to see the screen, if you're able to do that, has two components. The receptors in the retina of your eye. You have the color receptors, the cones, both begin with the letter C, and then the rods, which are for black and white night vision. The rods are very, very sensitive, but they only get activated when it's dark. They don't detect any color, but they do detect motion very, very well. And this was a part of our evolution. At night, we don't really care what color the thing is. We just want to see if it's coming to eat us.
Exactly. Does it have white teeth?
So does it have teeth, and is it coming towards us or away from us? So, but they're very sensitive, but they're very they're in black and white. Now, your body naturally switches over from the cone-based vision to the rod-based vision when it gets dark enough. Unfortunately, as I say, it takes about 20 minutes for all the chemicals in your eyes to accomplish this. But when you're fully dark adapted, it's phenomenal how much you can see under just pure starlight. But at any event, so as Paul was mentioning, if a flash of light takes place, even if it's only for a half a second or so, especially if it's a blue light from an LED screen like your phone or a headlight or someone's shining a light, it instantly turns. Oh, there's another one. You see that? Top of the screen. Yeah, another just flashing right. I don't know what it is about this video, but it seems, I don't know about anyone else, but it seems to slow things down. Does anyone else notice that?
Yes, and I'll tell you why that is. So they're using special low light cameras and to capture the faint objects that we see. So we can see the
great job.
We can see the time sync up there. So we can see just it is absolute real time, but the frames per second that the camera is able to take is slightly slower than you would be able to take during the daytime. Right, so that's why they kind of appear as if they're going a little bit slower than they actually are. So that's basically it. So keep your lights off. A red headlamp is absolutely essential. Red light, for some reason, red and orange light doesn't appear to affect your vision as much as white light, but blue light is daytime, and your body thinks, okay, well, it's time to switch over to color vision so we can start gathering our own food as opposed to just becoming food for something else at night. So, but it is really, really, so anytime you go to an astronomy event during our workshops, we always keep lights off. If you go to, as Paul was mentioning, the observatory, there's no lights on the observatory for just this reason, because light is not your friend in general. But yeah, it's a good point. We were talking in last night's Star Party, weren't we, Mike, about even the LED light. So on the speaker that I'm using here, a little LED light.
Oh, sure, yeah.
It's on quite a bit of the astronomical equipment, like the focusers and things like that we have, or the UPSs, or even the computers. We actually tape over them.
Absolutely.
And we can tell when the tapes come off, because that was interesting. In our night shots of the domes, you can actually, it illuminates. That one little LED will illuminate the entire.
Oh, it's amazing.
And you don't want that getting into your telescope view. Now, I just thought I saw something else there, Mike. Actually, there are two things here. This camera, the way it's set up, it's fixed. It's going to be fixed for the duration. Wow.
Oh boy, there we go. Man, this is like are we just on a loop? I think I saw that meteor before just a minute ago. I'm getting a little suspicious, because this is, I don't know, this is This is some good viewing right here.
Well, the nice thing is that they have this this time encoder working here, because they're doing a lot of science with this stuff. Now, that time coder is incredibly accurate. It's synchronized to GPSs and is overlaid. They even measure the latency difference between how long it takes the camera to kind of process the image coming in to get that in. But of course, we should expect to see them all coming from the same kind of direction, because we know Perseus is off there to the left. But one of the things I was going to just point out there is, if you remember, only 50 minutes ago, when we started the star party, this little blob here is not a star. That's the Andromeda Galaxy. And actually, if we were able to see its entirety, one edge of it would be here, and the other edge would be all the way over here. It's absolutely enormous. Its apparent size in the sky, it's an enormous thing anyway. But if you remember, it was over here on the edge of our frame. So Mike, just explain what's happening here, because it's relevant to the radiant that you were talking about.
Absolutely, yeah. So if you, so as Paul mentioned, the view that we're looking at here is roughly, I would say, northeast. So east is on the right-hand side of the screen, and north is on the left-hand side of the screen, where you see the purple globe in that direction. So in other words, if we were kept looking in this direction until morning time, we would see the sun coming up on the extreme right-hand side of the screen and then go off to the side. So what's happening here is we saw the Andromeda Galaxy M31 that Paul was mentioning, and the radiant of the Perseus is just, you know, below that and to the left, and that's going to swing back, just like the Andromeda Galaxy is in motion. It's moving to the right and up. The radiant is going to move to the right and up, and it's this upward part in particular that helps us see more meteors as the night. Oh my gosh! So anyway, trace all of these meteors backwards, and that's where you'll find the radiant. So you're getting a. It's not hard in this tonight to see that.
These, Mike, are absolutely classic Perseid meteors. They're incredibly bright. You know, they can leave quite a persistent train as well. What's that about? It's not smoke. It's actually ionized atmosphere, isn't it?
Yeah, it's a really neat thing to see. And in fact, if we somewhere in my archives, I have a great little slow motion time lapse. So what happens is, as the incandescent gas, as the incandescence cools off, you have this residue of ionized air. Maybe there's another one.
Oh, very nice.
I mean, that's literally a dozen or so we've easily seen. Yeah. Just in what it's like a half hour, something like that.
50, we've nearly been going for 50 minutes, but yeah, I guess this feed 35 minutes. Yeah. Look at this one.
Whoa!
Oh my word!
Man,
so we can see them, Mike. That's a classic example.
Yeah.
That's way off from the other.
Yeah.
Oh, look, the telescope's moving. Can you see the telescope?
Oh,
moving?
I do. Yeah, it's probably like, okay, enough of this. I want to. So what happens is there's a little dust trail basically that's left behind, just like an airplane contrail sort of. And if you can actually watch this for several minutes as the upper atmospheric winds blow on it, and it distorts, and it's actually, you can actually see this whole thing moving around. So it's a pretty neat thing to be able to watch. But that was a spectacular one.
It was, and it was a long way away from the others that we've seen, which kind of, you know, illustrates the point nicely that you can see these wherever you look in the sky. Right. I mean, this is just lovely framing of this.
Whoever. So I mean, state the obvious. You will notice that the meteors are coming from left to right, because the radiant is just off the left-hand side of the screen, and if we were to move this field of view towards it, they would be coming towards us. But you will notice that from where I'm sitting, at least, everything seems to be moving from the left to the right. Exactly. Almost horizontally too, by the way.
Yeah, and you even see them going down to the horizon as well, right, below the radiant as well. You know, you really can see them anywhere in the sky. This is a northern hemisphere shower people in the southern hemisphere don't really get to see them. They might see a few, but they tend to meteor showers tend to be northern or southern hemisphere biased, don't they, Mike?
Yeah, it's exactly. Yeah, they don't wrap all the way around the globe. Yeah.
So when people are outside in their own backyards, listening to us as their meteor watching soundtrack,
yes,
there are quite a few objects, especially if people go out earlier in the evening or before dawn, actually, which is always my preferred meteor watching time. I always say, I said it last night, you know, if you have the option, get up a few hours early rather than stay up a few hours late, because the most meteor showers peak in the hours before dawn. Michael explain why that is in a sec. But if people are going outside to watch, to look for Perseid meteors, there are some other things which some people get confused with. So if I was to describe to you, Mike, a solid white dot of light that was moving across the sky at a very steady rate, what would that be?
Great question. And these used to be kind of hard to find in a treasure, but now they're much more common than you might think. But this would be the reflected light from a satellite. And what's happening is these are things that are, you know, orbiting the Earth, many performing vital functions. There's some GPS positioning satellites. Our cell phones are using satellites. So I'm a big fan of satellites. You know, I use them in my everyday life. However, what happens is they're so far above the Earth that they're actually bathed in sunlight. And in fact, that's how many of these satellites get their energy. They have solar powers that they convert the sunlight into electricity to power them. So from our point of view, though, when we're looking up, we can actually see this reflected light because they're essentially like a little ball. They're reflecting light in every direction on the whole. And so you can see this light, but as Paul mentioned either tonight or last night, sometimes they're spinning or tumbling and the light seems to flash as it moves across the sky. But it is kind of neat to see these things. I mean, one of the most prominent ones, of course, is the International Space Station, which of course is a very big satellite that has people living inside of it. But yeah, check them out. It's kind of a neat thing to see.
That always looks great in the Slooh all sky camera, the cameras that low light cameras that we have looking at the entire sky, and seeing the International Space Station go over when the shuttle was flying. Sometimes if that was on a supply mission, you'd see the International Space Station going over and the shuttle then following. But we tend to see artificial satellites in the first few hours of the night and the last few hours of the night. And that's mainly because in the middle of the night, any that are passing overhead are in Earth's shadow. So we don't tend to see them. So you do tend to see more at the beginning of the night, end of the night. So Mike, another thing then that people might confuse, if they saw something which was a flashing light which was crossing the sky, probably about the same kind of speed as one of the other satellites would, what would that be?
Well, that'd be an airplane. And those are very distinctly observed in photographs because you can actually see two parallel lines that have little flashes on them. Sometimes you can even make out the red one and the green, so you can tell which direction they're going. But yeah, it's very worth noticing because as you've just seen tonight, meteors only happen for a fraction of a second. They're over. And so from a photography point of view, if you have an object, which is, if you're doing, let's say, a time lapse, you're making a bunch of sequential images, and an object is in one of the image, and then it's in the next 20-second image, and then it's in the next 20-second image, and the next 20-second image. It's not a satellite. Or it's not a meteor. It's likely a satellite or an airplane. So it's easy to get confused.
It's one of the things that's so easy. There's something about seeing an artificial satellite, and it is a constant light, so it's not blinking. That's the easiest way of telling those apart. But it's just the steadiness that they go across the sky. And what you also see is that they disappear before they reach the horizon. because they enter Earth's atmosphere.
Oh, yeah, this is a neat thing. Yeah, yeah. So this is something that's also very obvious with a space station. And there's a number of apps. There's a website called heavensabove.org that you can get predictions for anywhere you are on Earth. And it's if you've never done this, it's always fun to take out some friends or your family and say, "You see that star over there? Just keep an eye on that section of the sky." And then all of a sudden, bam, out comes this little blazing dot of light, and it slowly crawls across the sky. And it's amazing what science can do. It's amazing.
You're a prophet. They think you're a wizard of some kind, that you were able to prophesy this bright light coming from the east or something. So, so anyway, look, we are watching the live feed coming in from our partners at the Institute of Astrophysics of the Canary Islands. This particular feed is on the neighboring island of La Palma. Now, you can ask a lot of people, where's the biggest telescope in the world? And a lot of people will say Chile, or some might say the Atacama Desert in Chile, might even say Australia. But the largest optical telescope in the world is about, I think I know where this is. It's about half a kilometer away, so it's 500 meters away from the largest optical telescope in the world. It's called the Grand Can. It's got a 10-meter mirror on it. It is an absolutely astonishing instrument, and here it is. It's located in the Canary Islands, and although they're slightly smaller, Slooh's telescopes are on the neighboring island of Tenerife at the Institute of Astrophysics of the Canary Islands, other observatory sites. So they're on 2 islands. It's interesting, actually. The Institute of Astrophysics of the Canary Islands is a single organization, but actually there's quite a lot of competition between both the observatory sites.
I'm sure.
As to who gets these big instruments. But the Grand Can telescope is just an absolutely astonishing instrument, and it's not that old either. Now, on the let's just take a quick look. Let's have a little recap of what's going on up on the mountains. So let's take a quick look at the latest image. So this is the Canary Islands Observatory on the island of Tenerife, where Slooh's robotic telescopes are located. You can see the volcanic cone over there. Did that update then? Didn't update. Oh no, it did update. So we still got loads of cars up there. We still haven't got the moon up, which is quite good for us. Let's just check.
That's right.
Del Tadicam. No, so we still haven't got the moon. So we're going to see the moon rising over here, which is actually the neighboring island. I'm just seeing a little light that's on the neighboring island of Gran Canaria. So that'll be coming up a little bit later. So, but things are looking pretty good now. Slooh's telescopes are just down here, so not as big as Grand Can, but Slooh members every single night. In fact, should we go and take a very quick look? I know we're meteor watching as well, but let's take a very quick look to see what's on the Canary 1 telescope. Now, this is a half-meter telescope. This is a live view from one of Slooh's telescopes, and we're looking at a bright star here. So unfortunately, it's not an incredibly exciting object to look at. But let's take a quick look at Canary 2, which is a 17-inch telescope, still enormous. And these things are equipped with ultra-sensitive CCD cameras. And Slooh's got loads of patented technology and stuff like that that works in real time to generate these live real-time color images. This is the Pac-Man Nebula. For all of you gamers out there, you can just about see its mouth here and its kind of round head. So it's got a kind of gaping mouth, the Pac-Man Nebula. So these telescopes are online every single clear night, and these are all of the telescopes up here. Chile, I think, might be online as well. We might take a quick look at that. But you can see here as well, we've had some astonishing views today from the Canary Islands Observatory during the daytime, because we've got a solar telescope there as well. And we've been looking at just absolutely astonishing views, live views of our local star, the sun. Let's take a quick look at Chile too, because we've got a Southern Hemisphere observatory as well. Down at the Catholic University. Oh, look at this. This is the Butterfly Star Cluster, and look who scheduled it. That was an opportune moment. For those who don't know, Michael Palucci, is Slooh's founder. Founded Slooh back in 2002. Went live to the public on Christmas Day 2003. This is, it's a star cluster. That's looking pretty nice. Come on, we've got to get back to meteor watching, haven't we? I'm sorry. But this is what Slooh members do every night. And they schedule the telescopes. But what you can do is you watch everybody else's live missions, is what we call them, when they're controlling the telescopes as well. So it's pretty cool. And there's clubs and groups of members who share the same kind of interest. So anyway, I digress there, Mike. Back to meteors. Now, we were talking about the cause of a meteor shower. Now, for those viewers who have only just joined us or joined us since since we talked about that, can you remind us what's causing the Perseid meteor shower tonight?
Sure thing. Well, so the Perseid, tonight's a special night because tonight's the night, last night, tonight is sort of a several day event really. But right now, as the Earth is orbiting the sun, as it goes around the sun once a year, where it is in the orbit coincides with an orbit of a comet. So you think of two donuts basically that both donuts are centered on the sun, if you will, but they actually intersect. And what happens is the donut from the comet is basically, remember the comet Neowise that we all enjoyed all over the, well, in the Northern Hemisphere at least, just a few weeks ago. As comets pass through space, that beautiful tail that we were all photographing and observing and enjoying is, as Paul was saying, it's a giant, oh, this is going to be good. It's a giant debris field, just a bunch of dust left behind in space that is, made up of a lot of different materials, but a lot of them are just little grains of sand and little pea-sized pebbles, just like you'd find at a landscaping outfit. And anyway, so when the Earth passes through this debris field, these little grains of sand hit the Earth's atmosphere and cause the air in the atmosphere to incandesce and to ionize, to rip the molecules apart into atoms. And when the kinetic energy, the speed, the energy of the dust particles coming in hits the Earth's, the air molecules in the Earth's atmosphere, cause them to rip apart. And that whole process causes them just to give off the light that we see as a meteor that all takes place in a fraction of a second. And because we're going through this especially concentrated, so to speak, patch of space that has all these particles in it left behind from this comet, this other donut, for tonight, last night, tomorrow night, perhaps a little bit, we have this unusually high concentration of meteors that then ends as we, I just
another one there, just on the left.
Yep. And then, the Earth carries on through its orbit. Maybe it's slowed down a little bit by the impacts. It comes around the Earth, and then this time next year, we'll see you back here because it'll be the same thing next year in 2021. So in 2022 and after that.
Now, some meteor showers, they have quite a long period of time when you can view them. I think just about every meteor shower has a peak, but sometimes that peak, just like the Perseids, can be spread over 2 nights. So in this year, it was last night and tonight, and it's because these periodic comets are coming around very often. Every time they come around, they leave all of this litter and debris trail, and it builds up over years. But let's remind ourselves, because we've had some cracking comets this year, haven't we? Oh, look at that one. That was really nice.
That was another one.
Oh, I just went to that too quickly, but we just caught it. Mike, this is a comet that Cameron McEwen, Slooh member, captured earlier this year. This is from May. Comet C2020 F8 Swan.
So look at
what are we looking at here? Because we're kind of looking at exactly what we've been talking about being the cause of the meteor shower.
So this is a beautiful thing, Cameron. So again, just to emphasize, these were all made with images from the Slooh telescope. So anyone watching is interested in doing the same sort of a photo project, you're at the right place. But if you look at the bottom image, you see on the very bright, the head of the comet on the left where Paul's putting the cursor. But look, all that big streaming stream of stuff spreading out into space. That's the tail of the comet, and that's what we're talking about. So imagine, if you will, that we're driving in a bus or a car or a train or something. We're going to go straight through this trail. You can imagine there's going to be a bunch of stuff. It's like flying through a swarm of locusts or something. I'm just going to be hitting the windshield, the cars. We go through this thing, then we're going to punch through and get on the other side of it, and it's going to be all over. That's what happens during a meteor shower. So this is a vivid illustration of the type of, this is a comet, just like this comet Swift-Tuttle that gave birth to tonight's Perseid Meteor Shower. Fortunately, the comet Swan fortunately or unfortunately, that comet's orbit does not pass through the Earth's orbit, so we're not going to have a meteor shower from this particular comet. But if we did, then we would. And
the other thing to notice here is it has a slightly different name. So the comet that causes Perseid Meteor Shower is called 109P. You remember right at the very outset, I said P, that was for periodic. It's orbiting the sun. This comet Swan, is saying C/2020. This is not a periodic comet. This one is possibly even a one-time visitor, but if it does come back, then it's going to be in hundreds or thousands of years' time. But the other important thing to notice here is what Cameron's done here is he's actually given us a measurement of how long the tail is that you can see. Now, don't forget, the debris trail goes on for however far this comet has been, but he's actually measured this at 4.1 million miles. Now, even when we look down here to the coma and the close-up of the coma, this is the comet's head, we're not looking at a solid body there. What we've got hidden underneath that coma, which itself can be tens of thousands of miles across, is a tiny nucleus, and that's what people call the dirty snowball. It's made up of ice, volatile ices, dust, rocks, pebbles, these sand grain sized particles that we're talking about. What forces all of this dust off the comet's nucleus, Mike? Because the nucleus itself, Comet Swift-Tuttle, 109P Swift-Tuttle, is the largest near Earth object, so that's of asteroid type or comets, that actually crosses Earth's orbit. But it's still only 26 kilometers in diameter, 16 miles in diameter. It is absolutely tiny, in comparison to, the coma that we're seeing and certainly the tail. So what's causing all of this material to come off?
Another great question. So when you think about it, and this goes back to a question we were asked on an earlier show, is how long is a comet's tail? And I gave an answer that I thought the tail was basically the circumference of its orbit, but I don't think that's quite right, because actually the comet has to come close enough to the sun to begin to release the material. So to answer Paul's question, what is in the tail? What is it how does that stuff get there? So if you think of what is the comet in the first place, the most common thing that you'll hear everybody refer to the head of the comet is a so-called dirty snowball. What that is to say is, if you imagine, here in Minnesota, we get a lot of snow. There's a lot of snow shoveled up in each spring, and you have this pile of snow that has a bunch of rocks and dirt and all kinds of stuff mixed in with it. And if you were to make a snowball out of that, that would be not unlike what a comet is, because it's this icy mixture of water ice containing these little rocky chunks, these little rocky sand grains and these little rocky pebbles. And what happens is, as that dirty snowball that's orbiting in its orbit around the sun, as it gets close to the sun, of course heats it up. And when the energy of the sun is enough, it causes the ice to essentially sublime into water vapor. It goes from ice into water vapor. That leaves a trail, but then it also releases the dust particles that were contained within that dirty snowball into space. And it's really the heat, the thermal energy from the sun that's causing the snowball to release the material that will then become the meteors that we see tonight. So tonight, every meteor that we're looking at originated inside the comet Swift-Tuttle's dirty snowball as its origin.
Ooh, just saying how many people are in chat at the moment. Loads of you. I was just checking to see if we could.
Oh, there was actually Yvette had a question or a comment a moment ago, and her question was basically if it's okay. So if we see a moving light in the sky and it's not a satellite, and it's not an airplane, and it's not a meteor, then what is it? I don't know. I'm gonna ask you that one because I think I saw the little alien head.
Definitely, UFO has to be, and that doesn't have to be an alien spaceship. It is just an unidentified flying object.
Indeed.
But there was an interesting image that I saw, nightscape image that I saw, and somebody was asking the question, "What on earth is this?" And there's this trailing light going all the way across. It's a beautiful image. It's some rocks and stuff like that, and the starry background and stuff. And then there's this wheelie line going all across it, and it kind of looks like it's up in the sky. It looks like a UFO, but actually, they got to the bottom of it. It was a moth flying around, being illuminated by a nearby light, and you could actually see this sporadic path that this moth was taking. So there you go with that. My bet is moth. Have we got any other questions? Don't forget, you can ask us questions in Slooh chat. We made some changes this recently, really positive response we've had to that. So thank you, everybody. But I think we're going to go back to Gretchen saying adorable. Almost 15 minutes of fame, exactly. I mean, it's a lovely. I'll try and share it actually tomorrow in the club because
that would be. You know, it's funny. I was doing a couple of all-night time lapses these last couple of nights, and I have these lens heaters that I wrap around my camera lenses to keep the dew off. I hadn't really realized this until moving to Minnesota, but lens heaters are great mosquito attractants. And so I've got these this time lapse that's meant to be shown in a planetarium. And it has, I'm just trying to envision how it's going to look. I have this like enormous full dome of the night sky, and you get this like, 10-foot long mosquito outline showing on the edge of it. So
we on the all sky cameras at the observatories, these low light cameras that look at the entire sky, we have had some visitors over the years. They operate during the day as well. So we've had some birds. And of course, the bird is standing on the top, so it's not a particularly attractive perspective that you have of the wildlife. But then we have had nesting spiders. The worst one, we did have an observatory in Australia at one time, and I went down there for a maintenance visit. You don't want spiders, Australian spiders, all right, in your all sky camera. The Australians down there, it was a fascinating trip. While we're keeping an eye open for more Perseid meteors in this live feed from Tenerife. There was a crawl space underneath the observatory, so it had a lot of telescopes in it. Basically, a very large shed, and this crawl space, which is about 750 mil high, about 3 feet high, and I needed to run some cables, and I just didn't think anything of getting under there. And the Australians, these big butch Bruce blokes, were calling me crazy. They said, "What on earth are you doing?" And I soon found out it was just wall to wall black widow spiders.
Oh, geez.
Absolutely beautiful. I didn't bother them. They didn't bother me. But the rather large brown snake did. That did bother me. That went for me. Anyway, look, here we are.
Oh, boy.
We are looking at this live stream coming in from our partners at the Institute of Astrophysics of the Canary Islands in collaboration with skylive.tv. We've got Dr. Miguel Sierra Ricar, who has organized this feed for us. He manages the observatory site where Slooh's telescopes are based on the island of Tenerife. Did you see that one just to the right of the telescope?
No, I missed it.
And another. Two in 2 seconds. Come on. This is spoiling us now.
I know. This is one of those things. It's like when you're going to buy real estate, don't ever look above your price range because you're ruined. I mean, this is like I don't know. This is where do you go from here? I mean, this has been amazing. So this has really been an amazing display so far tonight.
Mike, we did an entire star party last night talking about how to photograph meteor showers. Now, we shouldn't go into any real detail there because Slooh members can go back and they can look at any of our star parties again. They're all archived and recorded. But I just wanted to say the kind of camera that they're using tonight is it really transformed the way the videography in astronomy. The cameras from Sony, and they're called A7S cameras, and they're incredibly sensitive, especially when used in video mode, and that's what these guys are using at the moment. This isn't A7S, it's what I was hoping to use if I'd had clear skies down here. But that's a pretty expensive camera. Now, what we were talking about last night is if any viewers have got even a really basic run-of-the-mill consumer DSLR camera or modern mirrorless camera, even with the kit lens, how can they photograph the Perseids tonight?
Oh, sure. Yeah, no, this is a great project. And I'd really encourage anyone who has a camera like that, who's interested in trying it out, to give it a try. There's been huge advances in the last 5-10 years that have made this a real possibility. And it's actually quite straightforward. So the main steps are to just switch your camera over to a manual focus mode. That's the most important, because you're going to have to focus it yourself manually. It's easy to do during the day with the focus ring on the camera. The autofocusing just doesn't work at night. It would be nice if it would focus on the night sky like some telescopes can, but it just doesn't work on your camera. So you have to do that yourself. And you can do that during the evening before, just by focusing on the horizon or a bright, faraway cloud or a mountaintop or even a street light perhaps. But you have to do the focusing yourself. And then you have to do the setting up of the exposure yourself, which is really pretty straightforward. You just set your camera to a manual exposure mode. That's the M button, M setting on your camera. It's a very powerful setting once you get used to it. It's the the program mode and the auto mode don't work at night, unfortunately. Cameras quite aren't there yet.
That's the one down on the left. Sorry, Mike.
Oh, no, I missed it.
Another one just behind the telescope. Do you see that?
Totally missed that one.
They're coming in pairs now.
Actually, it's an interesting thing, because sometimes they actually legitimately do come in pairs. That a meteor, especially a larger one, will break up into parallel. But anyway, so then those are the main things: manual focus, manual exposure. You're going to want to put it on a tripod or rest it on something. Just don't handhold it, because that won't work. And then in terms of what to set your camera settings to in the manual exposure mode, we were talking about this last night, but a good place to start is with an ISO of 3200, an aperture or an f-stop of around 3.5 or 4. It's not, it's not critical. And then a shutter speed or a duration of the exposure of around 10 or 20 seconds. And by the way, when you set your camera to 10 or 20 seconds, most cameras, the 10 has like a little a quote mark next to it. If you just set it to 10, that's usually 1/10 of a second. So that's much too short. So you want to set it to 10 seconds and then kind of adjust with you can adjust the shutter speed, maybe a little bit faster or shorter, the ISO. And if you want to learn more about that, please join our Nightscapes Club. This is what we do in our Slooh Nightscapes Club, one of the clubs that Paul was talking about. We have a great community, had a bunch of members, very active. We're posting things all the time, moths and moons and comets and stars and meteors.
Mike. Quick, sorry to interrupt. Just wanted to point this out because this is a live, we're watching Perseid Meteor, so I just hopped over to here. This is the Chile 2 telescope. This is a live feed coming from there. And we can see a star field here, but look, there's this white line going through it. What's that, Mike?
I don't see the white line.
Oh, you don't? So it's starting here and it's cutting right across the image here.
Yeah.
So we're fairly early on in the evening in Chile. So what we were saying earlier, what do we reckon that is?
That's a satellite.
Yeah. So and it's a satellite because we know that the exposure was taken probably for 50 seconds there and the satellites moved all the way through it. It is very, very rare to capture a meteor in the live telescope. Because frankly, the fields of view are so small, you've got to be very lucky. But actually there are a couple of members who track artificial satellites, especially spy satellites. But what I actually came over here to do was to show people, if you go to the hamburger menu down to Star Party, and if you use the sort by most recent here, so Slooh members can watch any previous Star Party going back to all of our eclipses, donkeys years ago, aurora visits, and northern lights in Iceland and stuff like that. But you can see here that Mike and I did a show last night where I was basically grilling Mike to get all of his expertise in how to shoot the Perseids. So don't forget, Dr. Mike Shaw, our co-host tonight, is one of the best nightscape astrophotographers in the world. And Slooh members get to learn from him every week during his Nightscapes Star Party. So, Mike, I haven't made you go red yet. What else do I need to say? Oh,
and during the week, too, we have an ongoing chat discussion. So
yes, in the club.
Certainly, I'm just trying to think. I was just thinking about I've got some, I could show some images. I've got some, meteor images we could show that illustrates a few of the points if we have a time to pop those in. But I'd hate to tear ourselves away from this live view. That's the only thing.
Well, we can pop away, can't we, for 60 seconds?
Let's do a quick 60 seconds. So I'll just show. So I'm going to do a share.
I just saw one. That was perfect.
No, I don't know. I think that we might have a mutiny if we start losing people after I do this. Let me know, and we'll like call them up and let's see if we can. All right, so it's asking me for you to stop sharing. So I don't know if that's a thing that we want to invoke or not.
There you go.
Okay, so we're going to
stop sharing.
Go over here. So there's two images that I wanted to show from this morning, just to illustrate. So this is one from early this morning, and this is kind of a type of photography we do in the Nightscapes Club, and it kind of just illustrates how I won't say unremarkable meteors often are, but when they're not huge. This is a wide angle lens. This is just a empty area north of Minneapolis, and you can see the double cluster, which is right up here. So that means the radiant is going to be somewhere over here. And sure enough, you can see this. If we zoom in on this meteor, you can see this type of stuff that we were talking about. It's very bright here. You can see a greenish tail, a kind of magenta thing there. So that's that one. And there's another one just not that far off from that. That's the one I was just, where did I go? I've got like Paul, I've got a dozen different screens here. I
am, by the way, keeping an eye on the live feed. We haven't missed one yet.
Okay.
Haven't missed one yet.
Here we go. So this one is now, here's the double cluster again, but this one, if we zoom in, unlike the other one, this one appears to be going up, away from it. And so what we can do is, you can see the tail of the comet here, and again, the radiant is over here someplace, and that makes perfect sense because this is what we've been seeing all night. I had these prepared in case we didn't have any meteors to share, but it turns out—
you doubter, you absolute doubter.
But if you put them all together, this is the type of image you can get where
beautiful.
You can really see, and again, this is hard to see just with the individual images because you're looking basically straight at the radiant. And so as Paul was saying, the meteors are all relatively closely aligned. But you can see here the double clusters here. So this was back several years ago. You can see that the radiant is not in the position that it is.
Mike, that was a good illustration of what we were talking about earlier. When they're closer to the radiant, they appear shorter usually. So the further away they are, you get out to these Earth grazers that are right up at the top.
See, each of these is a very kind of a short, just like the ones we saw a second ago. But now we can go back to one of the ones that we were looking at last night. And in contrast, if you look on the other side of the horizon, then you can see these much longer, more parallel meteors that all seem to emanate from the radiant, which is, from this perspective, behind us and to the right. So I'm going to stop that because I want to get back to the live view, Paul. So I'll turn things back over to you. But that's just a hint of some of the things that anyone here is interested in doing some nightscape photography, just come on over to the Nightscapes Club at Slooh and we'll get you all set up.
Okay, so can you see the live feed again?
I can, yeah, thank goodness.
Jolly good.
I was feeling a little stressed out, but not, you know.
No, I was keeping an eye on it, and we didn't miss a
Okay.
single meteor. You'll be pleased to hear. Otherwise, your name would have been mud. You wouldn't have been
would
able
have
to
been
show
like
your face here
We haven't
again.
even talked about bolides yet, but I mean, that would have been the bolide moment for sure.
Oh no, don't say that. We definitely would have done a replay on that. But you know, we can see here, you know, we can see the time ticker going over. It's GPS, incredibly accurate.
Sky getting a little
timings.
bit lighter, or is that just my imagination?
It could be. We've probably got.
Oh man, that was the nick of time.
If you had been sharing your image during that. My word,
Oh,
I
just saw
think
Gretchen come back to her chair. Oh, yeah, you really missed it.
we don't normally
it was
do
just
this,
another
but I do think we could maybe.
It was just only about a third of the screen, you know.
Let's see if I
That's
can
one of the
get
great
that.
things about
There
this.
it goes. There it was.
Man, look
Oh,
at that.
very nice, very nice. Right, let's go back to live.
Nice.
That was a very nice one, wasn't that?
That was a good one. Yeah,
I think that's the longest one that we had so far. Now, Mike, what we're seeing quite often with these larger ones is it's not an even line.
No, yeah,
And sometimes you get the head of it looks, the last bit of it kind of looks slightly different. Is something happening? What's going on there?
yeah,
to
definitely.
cause
Well,
that
I mean,
asymmetry?
yeah, these are things that are very. I mean, they're natural phenomena, so they're very irregular. And so, if you think about any dirty, or this is a meteorite. So if you think about any pebble that you go out to the seashore and pick up a rock or anything like that, it's not a uniform thing. It has irregularities. It's maybe one side's heavier. It's not perfectly shaped. And so all these irregularities play out as the thing is incandescing through the atmosphere. And sometimes the meteorite will break up into a bunch of smaller pieces, and then they will have their own separate trails. And so in any event, as the meteorite is coming in through the atmosphere, sometimes it's a very clean, thin little needle-shaped meteor, but sometimes, especially with the bigger ones, it has a lot of structure to it. And in fact, if you look at some very detailed, high magnification telephoto images of the meteor tail, you can actually see almost a corkscrewing effect, which is not atmospheric turbulence. There's been a certain amount of debate about that in the community, but it's actually, you can see this corkscrewing effect as this thing's coming through the atmosphere. So it's, when you think about the aerodynamic forces on the object as it's passing through the atmosphere, it's just phenomenal. So yeah, it's a real phenomenon, and it's just part of nature's irregularities.
Listen, a little bit of a reset if viewers have only just joined us. You're watching Slooh's Star Party live for the 2020 Perseids Meteor Shower. I had a little bit of a debate with somebody the other day whether or not it should be Perseid Meteor Shower or Perseids Meteor Shower, because you do see it written up as both, but surely it has to be in the plural. Certainly from our views tonight is definitely in the plural. But anyway, Slooh kind of does this kind of stuff every night. We congregate around Slooh's live telescope views. Tonight we've got these special views using special low light cameras from our partners at the Institute of Astrophysics of the Canary Islands. We also had them from actually the from Sharjah in the Middle East. That was from the Sharjah Academy for Astronomy, Space Sciences and Technology. Now they are just coming up to very close to dawn. Let's just take a quick look. I think they had to give up the ghost because they were just clouded out, which was really quite strange for this time of year. Andrew Dumbleton, Slooh's operations manager in the Midlands of the UK, me down in the southwest of England. We had feeds lined up from here as well, but we're totally clouded out. We've got great big thunderstorms and stuff like that, summer thunderstorms, which are quite rare here in the UK. But thank heavens for Slooh and our partners at the Institute of Astrophysics of the Canary Islands, where they've got two feeds, one coming from Tenerife, which is this feed that we're looking at, and the other one, which has been the spectacular one so far, has been on the island of La Palma, known as the Green Isle. It's absolutely stunning. I mean, the Canary Islands are stunning, but La Palma is certainly the most beautiful. It gets quite wet, hence the greenness of it. They shoot a lot of movies up on Tenerife, on the volcano there. I think they did there's some Star Wars bits there. They do moonscapes there. Oh, and they did one of the Fast and Furious films as well over there. And I know that because the people who take all of the big domes and big telescopes that we ship over there, they brought in loads of the cars for that. And apparently all of the men on the island had their head shaved to look like Van Diesel. But unfortunately, it takes more than just shaving your head to look like Van Diesel. Anyway, we have been watching tonight some absolutely spectacular. I know that's an often used word by me, but
this is really a thing. I think we should call this the Fast and Furious Perseid show.
I like it.
Yeah,
that's a nice little segue. Gretchen enjoyed that. By the way, if you don't know what I'm talking about, Slooh members on our star parties, they get to join in the fun. And they join up. There they all are. Wave, everybody. Wave, be friendly. Social astronomy and that kind of stuff. Yeah, very good. Thank you. That was Russ Glenn there as well. He's watching in, our Director of Education. So if you're a student or a school or a teacher or a college or even an astronomy club, and you want to get live astronomy into your classrooms or for homeschooling, we've got a new product for homeschooling pods, then email russ@slooh.com. And Russ will tell you all about that. But a lot of our membership are just individuals spread around the globe. We kind of think about Slooh as being social astronomy because this is what we do. We gather around these live telescope views every night, watching some absolutely beautiful live views of all manner of celestial objects, nebulae, galaxies, star clusters, comets like we've seen, planets, the moon. My word, we've had some absolutely stunning shots of the moon over the last month. We've been using special missions set up using those big telescopes to look at the moon in glorious detail. But tonight, we decided to share this with the world. So everybody out there on interweb land, if you're watching on Twitter or Slooh's YouTube channel, you really, if you're interested in this, then frankly, you're going to be interested in joining Slooh and using the telescopes. There are a load of people, little Perseid meteor then just shot in from the left. If you are really nerdy, there are small groups of really nerdy Slooh members who monitor and track near-Earth asteroids and comets, so do a lot of science with the telescopes. But a lot of other members, a bit like me actually, we just love watching and learning about these celestial objects, and we watch them live together. Mike, what's your favorite aspect of using Slooh's telescopes? Didn't warn you I was going to ask you that, so put you on the spot. I'm giving you a little bit of time now to think. Did you see that one? Lovely green one. You missed it. No, you see, you were looking away. You always miss the best ones when you look away. Go on, Mike. What's the best part of using Slooh's telescopes?
To me, really, it's the ability. It really is the ability to observe these objects that you just hear so much about, and it's so easy to do. It's so easy to use the telescopes and set up missions. And I do a lot of nightscape photography. I've been doing this for many years. I use cameras with fairly wide angle lenses, and to me, I mean, one thing I really enjoy about astronomy and getting out into the night to do the photography is to have that connection with the night sky, where you're actually able to feel as though, Paul was talking about reclining in his chair and just looking straight up. I love to do that because you can really appreciate the three-dimensionality of the cosmos. And when I come back and I have these like wide field images of, I was just showing you with a little bit of a marsh perhaps in the night sky, there's these little objects in there that aren't stars. And it's just fantastic. This is what we do in the Nightscapes Club, is we connect the deep sky objects like the planetary nebula that we were looking at last night, the Andromeda Galaxy we're looking at here, the Triangulum Galaxy that we could look at here, and all these different objects, Jupiter and Saturn we saw a moment ago, the Lagoon Nebula, all these objects you can actually zoom in and look at them and check them out and snap photos and share them around. And it's just, and of course the quests, but that's a topic for another day. Oh,
Now, that was not a Perseid.
that was not a Perseid, was
Because
it?
it didn't come from the radiant. We know the radiant
no.
is over here on the left.
Right.
I think it was Frank has just told us that the radiant is 21 degrees above the horizon. I'm surprised it's not a little bit higher than that by now. But that meteor did not come from there. So that was a sporadic meteor, and we see those every single night. And in fact, when you're up on these mountains at these dark sky sites, you do see so many of them. And what I usually do is, if I've been working on the telescopes, if I go over there and maintain them or install something new, I always treat myself. When I go back to the car to drive back to the residencia, I lay on the bonnet and recline on the windshield and just treat myself to half an hour of just peace and tranquility.
Oh, that's fantastic.
And the problem is, when you're looking at meteors like that, and I do it even if I'm watching a shower like this, I always say, I'll stay out for just one more. And before you know it, you're 2 hours.
I know.
One thing I did want to point out, we're talking about the radiant getting higher, but if we look up here now, so this camera has been facing exactly the same position. So the big telescope there that we see in front of us has not changed, but we can now see the Andromeda Galaxy all the way up here. Yeah. When we started off the show, the start party, it was down here, and we've seen it track all the way up here in an arc coming up. And that means that we know that the North Celestial Pole is off up here, up to the left, top left of our image. And that's the Earth spinning. It's not the stars going around us, Mike. It's us going around underneath them, isn't it?
It is. But here's an interesting thing on this point, because this is actually a very nice calculation that anybody can do. So when you think about it, the Earth rotates once a day, obviously, and I think we can agree on that, which means that everything in the sky rotates roughly 360 degrees in 24 hours. So that means that the objects are moving in the sky along their trajectories at an angular rate of 15 degrees per hour. Now, if you were to trace out a line that Andromeda has moved from where it started at the lower left, and just make a circle, or just trace its path upper right, we know that it's been going, since we first started, it's been about an hour and 40 minutes. So we could approximate that as an hour and a half. So in an hour and a half, that is 3 half hours. If you divide that line into thirds, then you know that each third is, I'm sorry, my brain's not working right. So you divide that into 1.5. So you take the 2/3, and that 2/3 of that would be 15 degrees. So if you know that that's the angular width of 15 degrees, you can then estimate we don't know anything about this camera. You can estimate the field of view of the camera, both vertically and horizontally, roughly, and just gain some insight about what's going into the sky. So that's, as a photographer, I'm always thinking about what's the field of view I'm looking at, when are we going to see the radiant come into view, and that sort of thing. So I might just make that quick observation.
Mike, what's the time over there on the in the United States of America? Let's say the East Coast.
Let's say in the East Coast, it would be, here in Minnesota, it's 7:45. So on the East Coast, it would be 9:15 p.m.
Okay, so people might be starting to think about whether or not to venture outside.
Oh, for sure, yeah.
Do some meteor watching themselves. So what are your recommendations for people who want to go outside into their own backyard?
Oh, yeah.
If they can pull themselves away from sleep.
Well,
did you see that?
Oh, yeah.
Just went straight into the telescope.
Yeah. Well, I would say just give it, just give it a try. And, just if you see a meteor, that's great. If you don't, you're going to see something. And bring out perhaps if you have an app on I know we were talking about the night vision, but if you have an app on your phone that has a star finder on it, maybe try to pick out, if you can find Jupiter in the south, you might be able to find Jupiter. You might be able to find the Big Dipper. You could follow the handle to the bright star Arcturus, if you're in the Northern Hemisphere. If you can find the North Star, Polaris, you can use the pointer stars in the Big Dipper to find Polaris. If you find Polaris, you can go over to the right a little ways, and that's where the radiant is, really right and down, depending on the time of night. But mostly just, to me, especially if you're just starting out, just see if you can identify a few things, because there's the thing is, once you've identified something, it's with you the rest of your life, you know, except for Jupiter and Saturn, which are constantly moving. You know, the moon's going to come up around, you know, 1 in the morning or so, 12:30 a.m. We can try to anticipate when that happens, watch what happens to the color of the sky. I think, you know, as I mentioned, this sky to me is getting a little bit brighter, perhaps, maybe not. It could be my imagination, but most of all, to do it, just enjoy the night sky, enjoy nature, enjoy the sounds of it's summertime, you know, the sounds, the smell, the feeling of the air, the bite of the mosquitoes. It's all part of the package, you know.
You know, but that's a really important point, though, because if I was going to give any tip to anybody wanting to go out, you know, to do some meteor watching, to me, it's all about comfort. And this is just as important, you know, on a summer meteor shower like this, and it is wrapping up warm, you know, for one of the big winter showers. But most of all, it has to do, I think, with how you're sitting. And I would certainly always choose a sun lounger over a chair, because tipping your neck back, or just sort of one whizzing right off the top of the feed, tipping your neck back within minutes, it just becomes so uncomfortable. But blankets, even on a summer night, because you can get pretty cold. But the other thing is, I always say, take snacks, take drinks, whatever you're going to want, take them out. Oh, look at that one. That had a beautiful persistent train behind it. So we kind of saw it almost hang in the air. That was a stunner. And once again, still pointing back to where we know Perseus is. Just off on the left, but comfort. So take everything out that you need at the start of your session, and then you haven't got to go inside, ruin your dark adaptation. But sun loungers, so lay down 45 or 30 degrees back, make sure it's nice and comfy, and just look up. I would not actually, if I was going out meteor watching, Mike, I wouldn't be trying to spot other things. You know, because as soon as you start pinpointing, you know, is that Jupiter, you're concentrating on that. You build that tunnel vision, and that's what you're looking at.
That is true. Yeah,
and you're going to miss the meteors, you know, in your periphery. There are other nights to do.
No, you know what? That's that's an excellent point. I always try to take it all in, you know, and sometimes
exactly. But it's like you and I. It's like you and I on Star Parties. We always try and squeeze far too much in to a single Star Party.
Yeah, I mean, so to that point, I thought you were going to say I wouldn't bother to bring a pair of binoculars, because I certainly wouldn't do that. If you're looking through binoculars, you're certainly not going to see the whole sky.
Exactly, even more tunnel vision.
No, you're right.
And that's one of the lovely things about a meteor shower, that you don't need any special equipment.
Right.
And you know, if you haven't been out meteor watching in person in your backyard, if you have a DSLR camera, don't try and take that out tonight. Go out and just enjoy it visually for this one. And then you can practice your nightscape photography on any night, you know, and practice makes perfect, doesn't it, Mike? How long have you been doing nightscape photography?
Pretty much as far back as I can remember. I mean, it's just one of those things that, and there's always things that go wrong. I won't bore you with the stories, but last couple of nights have been pretty good, except we had a patch of clouds that rolled through around 2 and 3 in the morning last night. But you know, it's just a lot of fun, and it's like anything else in nature. It's a natural. It's nature. It's unpredictable. It's predictable and yet unpredictable. So I think that's part of the fun, is that it's always a real experience, and these are the memories that you'll remember. Is the night you spent outside watching this stuff, and just for a moment forgetting all the other things about life, and just making that reconnection, because you can do that the rest of your life. It's like a security blanket to me, I guess.
It is. And you talk about the reconnection, you know, it is a reconnection that you get when you gaze up at, you know, dark skies like this. And, you know, you can actually see, we're looking at the Andromeda Galaxy just up here, that smudgy little patch, just up here. You can see that with the naked eye. Especially after you've been outside for 30 minutes. And if you do have a pair of binoculars, put a pair of binoculars on it, and you actually do start seeing, you know, its spiral shape. You don't pick out much detail. But so there are other things as well, and if you are outside, you can take a pair of binoculars out. Don't try and spot meteors with it, but there is the Perseid double cluster, and we were doing the show. It was last night. It was one of the star parties last night, and we just happened to be talking about the Perseid Meteor Shower, and there was somebody who had scheduled the telescope for the Perseid double cluster, which was rather cool to watch. But okay, come on, we need another one, don't we? We need another one.
Well, this is how it goes. I mean, the moment you start, you sort of get complacent or you start getting greedy or something. I mean, the stuff that we've had tonight has, I don't know, maybe it's the camera they're using or something, but it's just been, because the last couple of nights I've been out, and granted, it's not been the peak per se, but I haven't seen as many as I haven't in past years. So, of course, I've been shooting in not at 8,000 feet and, far away from things. So it's
exactly. So here is the view. So this is at 10,000 feet, a camera looking right down on the kind of ridge of the volcano in Tenerife, which is at 8,000 feet. I suspect that is probably Jupiter, although I think Jupiter is probably a bit further. No, Jupiter's probably a bit further on than that by now. But what we're not seeing yet, Mike, quite nicely, is we're not seeing the moon rising above the horizon. Let's just make sure the time. Yeah, the time is good on that.
Little moon glow there.
Well,
I'm angry at the moon right now. The moon's been kind of wrecking my photography the last.
We'd see the moon here. This is where it would be rising, because this is looking roughly east. We can take a look at this other view as well. See if this is updating. It is. So what that might be moon glow. Oh, just
I saw that
off the edge. Look at that. I'm glad I didn't maximize this window. But that's a neighboring island of Gran Canaria. The moon might actually be rising behind it. So the glow that we're seeing there could be the lights from Gran Canaria, but that could be the moon. And we can still see there's loads of people still up there, and they've all got their car headlights on. Switch those lights off, and you'll see far more meteors. So
the dark adaptation is really, I mean, it's really underestimated, because it's very unfamiliar to most people. I found over the years is that we pull into a parking lot. It's in the middle of Death Valley, for example, and there's no lights around, moonless night. And you get out of your car, and everything, you've been accustomed to looking at this headlamp lit road, and you don't have any night vision at all, and everything is. But then slowly things reveal themselves, and in about half an hour or so, you can just walk around very comfortably and see, not great detail, but you can see shapes and feel very comfortable at night. And I think this is such an important part to the whole endeavor to me, is that when that happens, oh, there's another one. Look at that. When that happens, when your night vision kicks in, you really, it's part of the whole connection thing. You really feel as though this shroud has been lifted, and you're fully in the night experience. And for a lot of people who have never really experienced that in a dark location, it's like seeing Saturn for the first time. People realize there's this whole side of nature that is available to them, that just requires, getting a little bit out of their comfort zone. But then all of a sudden it's like, a kid in the playground. It's like all these new fun things to try out. So it's just a lot of fun to be part of that.
You just carry on talking for a sec, Mike, because I'm just trying to sort something out
sure. Here. As part of that theme is just to carry on with that is, if you look at these stars, this is something I know I've hit on in the past, but what's so striking is when you do what Paul was talking about, you recline in your lounger and you're looking up into the night sky. To me, the part of this connection also is just appreciating the really three-dimensionality of space. And I know I've talked about this a bunch of times, but I really feel quite strongly about it, that when you are able to realize that all of these stars that we're looking at are all at different distances from us, are spread out in space. The view from the International Space Station that the astronauts have is really not very different than the view that we have here. They're only, 30 miles or something closer to space than we are. They're above the atmosphere, so they don't have the atmospheric effects. But in terms of the practical appearance of space, it's identical. So to me, one of the great features of this type of observational astronomy is appreciating that we are, in fact, astronauts, all of us. Every night we get to open open the windows in our spaceship, planet Earth, and we get to gaze out into the cosmos and look at this marvelous three-dimensional universe each night that's clear. Here in Minnesota, it's not clear that often. So what can you do? But, you know, there's just always things to, you know, treasures to find. And it's just, you know, it never, ever, you know, ceases to amaze me how magnificent the night sky is and what there is to see in it.
What I was just looking up there, Mike, was the time of moonrise. It's 4 degrees below the horizon at the moment, so that is probably what we were starting to see on the horizon, just that little bit of moonlight there. Now, the other thing that I was just looking at, because I just happened to have my sky chart up, is I believe Mars might be in this view. It might be behind the telescope.
Oh, you think so? I might be. No, is it? Mars is. I think maybe. Oh no, I'm sorry. Take it. Has Mars come up yet?
Yeah, it has.
Okay, then maybe it is right behind the telescope then.
So I'm just trying to pick out some stars. So there is.
Yeah, I had it a moment
ago.
Okay,
so this is Triangulum, isn't it? Here.
Yeah, right there.
So there's Triangulum, and Mars is.
I don't know that I have Mars up.
I think actually Mars is probably behind the telescope at the moment.
Okay.
So it's quite.
Oh, wait a minute. No, you're quite right. Mars is definitely up.
Yeah.
It might be off to the. Oh, I see. Gotcha.
It's difficult to tell without knowing the entire field of view, the size of the field of view that we're looking at here.
Right. It might be just off to the right, actually.
Okay.
Just outside the field of view. But this is one of the great. Oh, there's another flasher up at the top. I don't know if you saw that one. That was sporadic as well because it was. Yeah.
So in fact, what we've got here then, Mike, is these stars here are actually part of Perseus.
Yes.
These ones here that we're looking at, and in fact, let's just so the radiant is. I'm just looking at this. I need to get here. The radiant is just off to the left there. So any Perseid meteor should be looking as if it's coming in from roughly there. Actually, I think it might be a bit low, about here, maybe off to there. So that's quite cool. Anyway, just looking at a sky chart there to have a look at that. Oh, that's Mars? There you go. It's behind the telescope.
Oh, you're right. Look at that. We just had a occultation of Mars with the telescope. You were totally right.
Oh, isn't it good when things happen like that? So
yeah, I thought it was anyway, so nicely done there. Yes, there it is. The red planet.
Very bright, very distinctive. It's looking good actually at the moment in Slooh's telescopes, especially the Chile telescopes. It's looking really, really nice. So
nice.
Mike, we can carry on going. Have we got any questions, folks, from Slooh members? Feel free to unmute. Actually, let's hear from Andrew Dumbleton, Slooh's operations manager. Andrew, are you still in cloud there in the middle of England?
We're just starting to see some stars now, but there is a thin cloud. They're not popping out very much, but I haven't seen any meteors or even for any other reasons, aeroplanes, in fact.
Well, I mean, this is one of the things, though, isn't it? With the pandemic, it's been an absolute joy for astronomers because there haven't been so many aircraft in the skies, and that has two impacts there. One, of course, being that we have less high altitude pollutants, so sky conditions are normally pretty good. But Mike, have you noticed any difference on that with your nightscape photography and the lack of aircraft?
Oh, no, definitely. It's funny. I was talking to some other folks about that, and I have definitely noticed a decrease in air traffic for sure. You know, I live in basically Minneapolis, St. Paul, Minnesota, and there's a major international airport here. There's been an enormous decrease in the amount of air traffic that is taking place, and you know, locally, and then overhead as well. So it's been kind of interesting to see that. You know, it reminds me a little bit of 9/11 because there was all the flights were grounded then as well.
I was talking about the light laws that they have in the Canary Islands, which is where our live feed's coming from the Institute of Astrophysics at the Canary Islands. And we don't get aircraft in our live telescope views at Slooh's observatory, because not only do they have a light law which prevents errant security lights and certain forms of external lighting, but they also have no fly zones over the observatories. No aircraft are allowed to overfly the observatories. So we never see an aircraft in the all sky cameras going over here.
Hey, Paul. Hey,
yes.
one of the interesting things in the Star Parties, talking to some of our members in India over the last week, I had asked them, because I had read in the States that, as we know, the pollution worldwide is down because of COVID. And a couple of our members in India were telling me that they actually, for the first time, are able to see stars at night now. Not a lot of them, kind of like a big city like where I live, but their entire life so far, the sky was always a blue haze where they live because of the serious pollution problems they have. So there's a plus for them that they've actually been able to see some stars at night occasionally now.
Gosh, that is oh, look at that.
Oh,
there you go.
That
right
was
to Mars. Look at
exactly that one was heading straight for Mars to pierce its heart. You're just reminding me there, Frank. I've told this little snippet of info before, but the first time I visited Slooh's Canary Islands Observatory to install a new telescope over there back in 2005 or maybe even 4, I was working at night. It was at the beginning of the night. I was getting everything ready, had my head down in the dome, and getting ready to commission the new telescope at night. And I looked up and I thought, oh no, new telescope, and all astronomers know what a new telescope equals. It equals at least a week of cloud. And I looked up and thought, well, there's no way I can do my work because it's cloudy. Well, I took a double look and the cloud wasn't moving. Little Percy just going down there from the bottom of the screen. It was the Milky Way. And it was, I had never seen the Milky Way looking so rich and so dense. I thought it was cloud. And the other thing that I always notice when I'm at either observatory, the Chile observatory as well, with the dark skies, it's really, really difficult to make out, to identify even the brightest of constellations like Orion. Because there are so many stars that are visible because there's no light pollution. There are so many stars visible. It's like it's camouflage. And I was astonished.
That's a great way to put it.
Yeah, I was astonished when I couldn't even, make out Orion. So that's it. That is it. They are packing up their live feeds in the Canary Islands. So thank you so much.
Well, thank you
to our partners there. That's the Institute of Astrophysics of the Canary Islands, giving us those absolutely glorious feeds tonight. Special thanks to Dr. Miguel Sierra Ricard and Miguel Rodriguez Alarcon, who have set all of that up for us. They do a Spanish language broadcast. We've also been on several of their eclipse expeditions as well, and tagged along on those, which have been absolutely stunning. The Kenya eclipse was probably the highlight of that, but we also did the Icelandic Aurora trip, and then so we've had some marvelous adventures with our partners at the Institute of Astrophysics. And if you are just viewing, if you're new to Slooh and haven't heard about us, and this is what Slooh members get up to every night. So this is Slooh's website. Let's take a quick look at the homepage. Lots of people on it, so it might be a little bit slow. But it'd be interesting actually to see what images people have shared. But we've got telescopes in the Canary Islands. Actually, let's just take a quick look, see if there's... So this is the observatory site. So this is a large telescope called the OGS, the Optical Ground Station. They zap lasers into the sky, and they also track rubbish, space debris and stuff like that. And we can see there are fewer cars than normal. This is always good. We're at 8,000 feet altitude in the middle of the Atlantic Ocean, well, on the side of the Atlantic Ocean. And we're above the clouds. That's the clouds being lit up by lights underneath. The moon is over here, so that's what we're seeing, just starting to lighten the sky over there. But Slooh's telescopes are just about where I'm pointing my cursor to there. And we've got a number of telescopes there. Look at that. Lamb Skinny.
Nice.
Lamb Skinny shares some absolutely wonderful observations. So on the Slooh homepage, we lay it open to members to share. And in fact, Lamb Skinny, that deserves a like for that one. Last quarter moon from yesterday, from last night's star party. Oh, that looks, is that really near-wise? I don't think so. It looks more like a dark nebula to me. Another last quarter moon that we were looking at last night. Oh, somebody, Michelle Park,
My goodness,
has shared that lovely Perseid that she caught this evening.
Wow,
Gosh,
way
nice
to go,
one.
Michelle.
Holy guacamole, Michelle is saying. But anyway, so, that is the first time. Is that? Yeah, that is a Slooh image. That's the first time we have caught Starlink. Ooh, that's interesting. That is the first time. We catch a lot of satellites, but I can say with a high degree of confidence that that looks like Starlink to me because of their
satellite tracking master.
yeah. So, wow, that's pretty cool. And some beautiful nebulae as well. But what they also do, what Slooh members do, is we look at and control the robotic telescopes down at the Chile Observatory. So what's somebody looking at here? This is Goran. I know that I know because he always puts this code in here. So actually his name's down there anyway. But he is, what's he looking at? He's normally asteroids and comets is Goran. We can see our all sky view here. So actually look, this is the all sky camera that I was telling you about. So this is in Chile. And we can see here the bright spot there. That's Jupiter. We've got Saturn just off to the left. We've got the Milky Way plowing through the center of the image here. We've got, this is well, actually, I think it is my favorite constellation. This, you can see the shape of the scorpion, Scorpius, and its tail whipping around here. And we've got the constellation of Sagittarius here, which is pointing to the T-spout, where the steam of the Milky Way is coming out. But there's the Slooh dome over here. So we installed a new telescope there, which I think is actually the most popular telescope we've ever installed at Slooh. It's the Chile 2 17-inch telescope. And we've been getting some absolutely marvelous views from down there. So that is the Chile telescope. Shall we take a quick look? We may as well at the Canary 1. So this is the half-meter telescope. What are we looking at here? What's the target? What's the target? Pelican Nebula, this one. Parag is scheduled this. So this is a Slooh member. That's interesting, isn't it? This is a Slooh member who has said, I want to view this object this particular time on this particular telescope. But all members can watch the live feeds. Not only can you watch the live feeds from all the telescopes, but hit that little button there and you snapped your own image from that mission, which is quite cool. Let's take a very quick look at Canary 2. What's going on over here? Oh, Grand Design Galaxy. This is a nice one, Messier 74. And we've got these things called quests, which are kind of activities that you can do. Mike writes them and I write them. And this one would be an absolute perfect one. I'm going to snap that actually. Grand Design Galaxy. For the Messier collection quest, where you collect 110 objects, celestial objects, from the Messier catalog. What can you tell us about this object, not specifically, but the type of object that we're looking at here, Mike?
Yeah, no, this is just a beautiful, beautiful illustration. It's very similar to the Milky Way galaxy, if we can see the Milky Way from afar. Again, all of the stars that you see surrounding this this Grand Design Galaxy are within the Milky Way galaxy. So it's like we're looking through them to see it. And it's just it's like hundreds of billions of stars. It's like we're looking at a different city from our city. It's, I don't know how many, millions or of light years or how old the light is, but it's coming from a very distant past. Yeah. And it's just a really neat thing there's like so many different avenues to go down in terms of the shape of it and the possibility of life. Perhaps there's another type of life there.
Sorry, I just switched it on because that is a very little known feature. When you're watching Slooh's telescopes, we have some narration. This one is Bob Berman. You were talking about Bob Berman earlier, Mike. So for the Slooh 1000 catalogue of objects, so these are our curated list of the 1,000 best of. Oh, this is going to be. We're never going to leave, are we? Because this is one of my favorite objects as well.
Now, let's pause for a minute here because this is similar to what we were just seeing, but edge on. And so that's the beautiful thing about space is that, and the universe and the cosmos is that, so if you were, let me put it this way, if you were to look at this object and think, what the heck is that? And then you look at the other galaxy and think, what the heck is that? It might take a while to piece them together, that there are different views of kind of a similar thing. So
yeah, that's great. But anyway, for the Slooh 1000, it's a curated list of 1,000 of the best celestial objects visible in the night sky. And for the vast majority of those, we have audio narration by a number of people. And that they're always worth listening to. Anyway, Mike, what else have we got any questions? Let's just check if we got any last minute questions. Otherwise, we will round up.
Yeah, I saw that Stan made a comment a while ago about the airplane traffic near him. So he sees the flights heading north for Newark. Last 2 weeks is starting up, and then Jake made a comment. He's under the Houston approach. From the south can be busy. Tardigrade is noting that the Chicago airport is picking up also. Hal is commenting about being apart from Detroit, and he's noticing the traffic is down too. So yeah, it's 2020. Noticeable. It's a crazy year.
Noticeable. Anyway, listen, I think we should probably call it a night. The folks in the Canary Islands at the Institute of Astrophysics at the Canary Islands have packed up their equipment, and they're doing that primarily because the moon is about to rise, and that will spoil the view dramatically. But my word, I think we've probably seen more meteors tonight and more really good meteors than we have during any other Slooh meteor shower show. And some of our meteor shower shows, say that quickly, say that at 2 a.m. in the morning.
Indeed.
Our meteor shower shows or our meteor shower star party shows. Some of those have gone on for 6 hours. We've done them all night before, and we have not seen that number of terrific Perseid meteors show. So, Mike, what are your last thoughts on tonight's star party?
Thanks for joining us. It's been a great night. As Paul said, this has been to me an unusually active display that usually bodes well. So if you haven't had a chance to get out, I'll see you tomorrow. But no, thanks so much for joining us. And as always, it's just wonderful to see people from around the globe as part of these events.
Yeah.
I mean, social astronomy is just such a wonderful thing. And this year, I think more than ever, we really need this. So I'm grateful to each one of you for taking the time out to dial in and to join in and to ask questions. And it's been a great time, Paul. So I was really glad to have the chance to be here. Thanks for asking me on.
I agree, Mike. I mean, you and I would, if we were here alone, we'd have a great deal of fun, but my goodness, it makes it so much more fun having all these Slooh members watching in as well. And for those who are watching on Slooh's YouTube channel or Twitter, then consider joining Slooh. We're a merry bunch. It's really a lovely community to be part of too, and it doesn't matter what your interest in space or astronomy is. It can be a rank beginner, or you can be into science. It doesn't matter. We've got the full gamut, the full range of members. Last little thing. Pooja's got a question. Got a hand up. Pooja, have you got any?
I do. So I have actually two questions. One is, are these meteoroids, when they come in the shower, at the same distance? So can we assume that the brighter ones are bigger in size than the ones that are lighter and small and lighter looking. Is that a good assumption to make?
Mike, I'll let you answer
Yeah,
that.
no, I think that's a great assumption. I mean, yes, they all are occurring on the same part of the atmosphere, the thermosphere, and it's all about the same height. There's some great images, by the way, of meteors from the International Space Station looking down. But yes, because they're all about the same height. I mean, some might be physically further away from you in terms of a horizontal distance. So those might be dimmer, but I think that's an excellent point. So yes, I would feel comfortable drawing a correlation between the brightness and the length of the meteor and the size of the meteoroid that caused it. So I think, I concur.
Did you have a second question, Pooja?
I do. It's about the comet. So when you were showing us the picture of the comet, it was blue-green. And does blue-green indicate that the comet is moving away from us? Is that well known?
Mike, tell us about this one, which is the latest comet that we've been watching. This is Comet Neowise.
Yeah, very great. Pooja, that's a great question. So thanks for asking that. Fellow
Minnesotan, by the way. Hi.
I beg your pardon?
Fellow Minnesotan.
Get out of here. So I'm looking out my window and seeing a bunch of clouds. What are you seeing?
Clouds, Eden Prairie.
What are you going to do? So great question. Do you come to the Minnesota Astronomy Society meetings by any chance? Sorry, guys. I'm just gonna.
No, I don't. I'll look
at over there. It's like they're doing these.
Talk amongst yourselves. Why don't you?
Anyway, so okay. So I think what you're referring to here is when objects move, towards us or away from us, they can be red shifted or blue shifted depending on the relative. It's like the Doppler effect. This is purely a chemical effect in the head of the comet. So these are carbon-nitrogen bonds. These are carbon-carbon bonds. It could be atomic oxygen. Oxygen's all over the place, and it gives us all kinds of greenish, yellowish colors in the aurora and air glow. But this is a chemical effect that is a little bit different. It's kind of, I guess it's similar to the ionization effect in the in the oxygen and molecules in the air's atmosphere. I say that those two things are correlated, not so much its relative speed.
Okay, thank you, Pooja, for those. You always ask such great questions. So I think it's time to say goodnight. I will see you on Thursday night, Friday morning for our very last lunar phase quest star party. Now, this is going to be a very old waning crescent moon that we're going to be capturing with the half-meter telescope to finish off our month-long quest where we've been tracking each lunar phase throughout the month. So I know that I'm probably going to be there on my own because the timing is not great for a lot of you, but we'll see. We'll see. This is going to sort the diehards out from the lightweights, isn't it? Oh, Milton's already volunteering. I can always rely on Milton to be there. So hopefully Stan and a few others. Yari will be there. Gretchen turns up to most stuff. Hal, you're always around as well. Listen, it really wouldn't be the same without all of you joining us in our live star party. So thank you so much for joining us on this special one. I'm so glad we got to see
thank you both for sharing so much.
Cracking meteors. That's our pleasure. We love doing this stuff.
Yeah, so. Thank you. It was wonderful.
Okay.
Very interesting.
It's great.
Well, that's it, everybody. Thank you very much. We'll see you again at the next star party. Mike, I've set up your star party for next Wednesday, your Nightscape star party. So you're now locked into that.
Excellent. Look forward to that.
Got any ideas what you might be covering next week?
I was thinking about doing a comet composite. I mean, that seems to be something that might be germane. So maybe we'll spend a little bit of time on that. But mostly it's just looking at the member pictures, answering, we have a very informal, kind of go around the room kind of discussion more than anything else. So we'll find out what people want to talk about. And then, of course, we do some great telescope viewing as well.
Okay. Thanks everybody.
Thanks, Paul. Appreciate it. Thanks, everyone.
Love to see you all.
Thank you. Good night.
Thank you very much.
Take care.
Bye.